Fellow professionals in the construction industry, we appreciate you for staying tuned. Young Quality Surveyors Forum, Oyo State Chapter, present you a video tour on bridge construction methodology. This video, I'll visit to the site along Ibadan Lagos Expressway, which involved the construction of bridges and interchange of Ibadan Circular Road. We met with including the consulting engineer, who gave a detailed commentary on the stages and processes involved in constructing Bridge 1 and 3. We are sure that your knowledge and expertise on bridge construction. Thank you and kindly watch to the end.
Video consulting engineers representing the Bridge Consulting Limited. We are here to talk about how the construction of Bridge 1 has been going from the beginning. It all started with the soil penetration tests to determine the level at which they can reach a very solid strata under the ground, and from their findings they discovered that at 30 meters beneath the ground the soil is still, they cannot meet a rock, so they had to go for pile foundation for this place. And the first thing is to drill for piles, and after drilling the piles, reinforcements for the piles are placed inside and they were casted with a grade C 30 concrete. After they were casted, the next stage is to check for the integrity that were casted piles. They are 1 meter diameter piles. We have 18 here, 18 on that other. All these one is approximately 8. So we have the left hand side, we have the right hand side. So we have 18 piles under pie cap. This is the pie cap. We have 18 piles underneath one pie cap. So making 36 in all. So after checking for the integrity of those piles and the passed, the next stage is to excavate to the depth at which the pie cap will be, the depth of the foundation of the pie cap. So we excavated until we reach that depth. It can be depending on the level of the ground. So they excavated, they blinded the place. After excavation, it will show those piles that were casted. So those piles were now broken down to that blinded level. So they were broken with a machine, or they use a concrete breaking machine to break those concretes. So they break it gently so as not to affect the piles under the road. So after that, reinforcements were brought in for the pie cap. Then after the reinforcements were formed, the pie cap, they were boarded and these pie caps were casted. So it's that these other reinforcements are now connected. As you can see, some of the reinforcements they have concrete on them already. Those are the ones that were casted into this pie cap. So these other ones that are not with concrete, they are just now going up to the height of it, depending on what the surveyors need as the height. So they usually use 20 mm. Depending, they can use 25 mm at times, depending on the design of the constructor. So then after that comes the form work for the wall, like we have on this right hand side. inside that we close. After the completion of the body, then it's casted. It's casted to the plate level for the main bridge. So this other head wall, we call this head wall and main wall, that is the casted. First casted on the plate level, where we cast the plates for the bearings, where the beams we now rest on. The beams for the bridge, the main beams we rest on. I will show you the main beams when we get there. So this is all about this. They are for pump work. They use them for. It's just for those these stands for the scaffold to hold the beam in place. So it's not compulsory, but they try to use it, as they use this reinforcement to hold this in place, to hold that stand in place. They can also use it here when they are boarding this, so to stand it in place. That's all they use it for. We have the piers. This is pier 1, left hand side, right hand side of pier 1. They all start with the the piling, drilling of pipes the same way, but the only difference is here we drilled up to 30 meters, but over here we drilled only to 23 meters. We have 20 of it all through. We have 10 on this pipe. After that, the same 30 they were excavated, and then they were broken with the concrete breaker to that depth. And then average here, I believe we have like 2.5. So after they were broken, the eyes were broken, they were blind, the floor was blinded with concrete, and then we have the reinforcement for tie cap coming in. After the reinforcement, they were boarded, and the tie cap was tested the same way. We have the reinforcement for the piers shooting out from they were not connected. Actually, those ones were not connected to anything. After they were broken, they added stock on them to farm them together, and so they are on the sides of these piers. This one are in between the pies.
It's the cap that is just carrying.
Yeah. The cap, they tie this one to the cap at the floor. Yeah, you have, as I said, the part of it like 1.5 meter shoot out from it, so that this one will now be connected to the remaining reinforcement for the piers will now be connected to. So each one of them is piers. And then after the piers comes the cross beam. I can still have the formwork for them. They first make the table of the formwork where the reinforcement for the cross beam will be. So after they form the reinforcement, they now place the sides of the formwork into it. And so once they are ready to cast it, they are done here and here. So then they cast the planes on them again. So they cast planes. We have 10 on this and 10 on that one. On this one we have 20. From here 10 we move and then 10 to the other part. So this is for head wall. Head wall for the cross beam.
Talking of expansion joints, where the
I mean, I don't understand the part that are placed on the spans of the cross beam. So, at Bridge 1 we are using two types. We have the 23-meter beams and the 21-meter beams. It's actually 20.8 and 22.8. These are precast, and after they cure, and they are up to 21 or 28 days before they are now lifted on the cross beam. So next, one main beam to another. Yeah. It's already been casted. They are now chiseled out to leave this reinforcement, and they are taken out from the concrete and then connected to another beam so that the joints can be one uniform.
Those are casting seats.
Yeah, yes, they've been casted on the deck. Yes. So we have the slabs, and then this is a type. Can have another type that we now have the slabs as a platform on the beams. But this one, the design has the slabs casted with it, so that it will create an ease of work for the decking that will come over.
Is this like a concrete formwork for the deck?
Yeah, it will serve as that, but it's also part of the decking.
What's the thickness?
This one is less than 0.1, less than 0.6.
Thank you so much.
And those those are just for ease of work. The form work, because this platform is just for the form work, to help them form the reinforcement on it. So when the form work is placed on this, they are connected through those holes to the other side, so that to farm it together to ensure that there won't be any leakages when being casted.
That is when they want to lift it, they are lifting all this.
Yes, they will lift all this, leaving this. That will be later fixed onto the sides of the beam to protect the passengers on the way. They are casted, recast, as you can see. So later, after the decking is completed, that's why they have the reinforcements out.
The long span of
Yeah.
each
We have a 2x2 bus culvert. It's 40-meter long, and it's all starts with the excavation of the area that we have the culvert on, and then we have the arrangement is casted. Then the formwork for the walls are then formed after the reinforcements for the walls are formed, and then they are casted as well. And then the decking of it is also casted. Then we have the ones that shoot out like this. We have the head wall, which is the top of it here. We have the wing walls. These two wings, they are called the wing walls. They are 200 mm thick, and we have the apron. This is this platform that shoots out. That's a trapezoidal shape. That's the apron, and then we have the toe beam. That one is underneath. So That one is about 0.1 meter thick. So it goes down to, and it's about 1 meter long, 1 meter deep into the floor, into the ground. So the toe beam
that's carrying the apron.
yeah, that's carrying the apron, that's connected to the apron.
Okay.
So it's just to fix the culvert onto the spot, not be able to move.
Okay.
So it's at both ends of the culvert. And then that is all about it.
Yeah, you mentioned 2x2 cover. Are you talking about meters?
Yeah, 2 by 2 meter. So
That
if you
is
mention
the cross-sectional area.
cross section and not the inside like this, the outside blind. 2 by 2 meter by 2 meter.
Okay.
Yeah.
The headboard.
Yeah.
And this is the area of
Yeah.
Thank you so much. These are hook posts too, right?
Yes. They serve us. But though they are connected for the formwork,
Oh, okay.
for the formwork, I believe. So they can serve as whip poles as well.
Okay. All right, thank you.
So we just have to.
Actually, that's why they didn't start the second electrical of this tier 2. So they only at the tier 2. Because if they are to start that one, because they will be limited to what they can do. It might affect the movement of everything. So as not to affect that, we focus on one part of it. So these platforms take somewhat for the process, like rapid. So that's why we want to focus on this. When it gets to the first, once it gets to the work here, this is here as well. So the same way they did here, they will excavate to the 5 foundation. So, but they manage the space here to the extent that they only different to in the other places they excavated working space so that they can place the homework and here they only manage the width of the pie cap, which is pipe. So they excavated like 5.2 meters. So 0.1 to this side, 0.1 to this side, and they use the on sides so as to protect the edgements. So and they place the reinforcement only to this side and to the other side, other hand. So and then they have the pie cap, they cast the pie cap and then here afterwards. So they come over. Outside the platform for the forward. So to have a solid platform. This alcohol will not be shaken under.
Realize that cross beam activities was
He has killed water come against any skilled object. It flows faster. So I believe it's for the external forces like the wind, so that it will flow away from the concrete. so it will flow faster away from it. Like you have in the case of water, how it flows easily when it's slanted or it's skewed. So I believe that's what was designed at Bridge 2. I believe that's the reason why they did it here as well. So external forces like wind and water, and also direction of the road, because the way this road is coming is not facing directly. It's not directly proportional to this. So we have to skew it from that shape. Here we have a completed abutment wall, remaining the head walls and the wing walls. Here they have casted the plinth on them, and currently they are backfilling at the end. Concrete and you have hardcore to solidify it. So that serves as just the base for the foundation. So it will level all the rocks. You know, rocks don't form in flat surfaces.
Yes.
So it will now level it, and then they will start the foundation, normal pie cap over it. So from the pie cap, then the piers. This one we have piers under it. This was just filled up.
It was just filled up.
Other things you are seeing. So we have the abutments on both sides.
So is it the same part?
After the crossbeam, this is the crossbeam circumference. Yeah, this is the main bit. Each gather rest later. This one together. Like a formwork for so you can have another design that doesn't have that.
Yeah, like only bridge at Nigeria. We did not have
In the beginning it was 1 to 4, 1 to 3, but depending I have not seen them pass any
So we are from the Nigerian State Council. Yeah, well done. So So what's the name?
My name is Fadi.
Ferdi. Okay. You are the project engineer. Okay. Can you tell us about what company?
This system is bridges for cyclopean. You know that this place, the rocks are shallow.
Yeah.
So we are working on it. We try to make piling, to make piles when we start working here. But because of the rocks shallow, we couldn't make piling because we couldn't make the piles more than 3 or 4 meter minimum. So we use the cyclopean system. Cyclopean system is mixed between concrete and boulders and hardcores. We level the rocks by the cyclopean, and we put our foundations. We start our piers, and as you see, this is in general the skeleton of our.
Thank you for your time.
Yeah, we are talking about the material coming out. The moisture also. We have the calibration sign here. The result is with us, giving the calibrations. And then the major, the tube, the testing of tube is done in the major yard. Crushing machine. This one is for this one really feed racing. Yes. And even we use it also for the calibration of sand too. Yes. So we have our base plates here. This one we use it to get our volume, the depth of the height of the depth that we are going to the soil. Now we are using that. Then other minor things are here too.
How about the moisture content machine?
Yes. This is just for speedy. There are different types of taking moisture. We have the one of oven dry, but this one is a speedy moisture. This one is mainly for the sites. Then we have our micro scale here. We normally take, we need like this particular spade. We have to take like 20 grams of material of the soil. Then let me so see how this. Okay. When you're coming. It takes some time before it zero it. You zero it, but once in a while we calibrate this one too. It's a standard weight here that we use to calibrate it. It's 100 grams.
100 grams.
Yeah, so it's used to calibrate it so that we avoid any error.
Thank you so much, sir.
Yeah, then we have a scale here. We normally read the moisture. The scale here. And we use the tablets.
Carbide.
Carbide.
Yes. We have some stone here. This to increase the surface area of the material during shaking, so that all the particles can touch all the particles. But without this, maybe some particles that will not be touched by the carbide. So with these stones, it will increase the surface area of the particles and spread it around. Okay. And then so that's these are the measuring cards for this sample.